This is sample 9-9 from page 404, and it's going to talk about follow-through for a tennis shot. In the slideshow, I talked about follow-through on a golf shot and how you could apply less force to the golf ball by keeping your club in contact with it for a longer period of time. And this example is going to discuss the same idea, but with a tennis player. So we've got a tennis player who can exert a force of 560 newtons. So if you're an athlete, the amount of force that you can apply in a certain position or a certain situation is pretty fixed. Like if you're a pitcher, there's only a certain force that you can use to throw. If you're a tennis player, there's only a certain force you can use. Now, you can increase that force by working out and practicing your technique and such, but on a given day, the force that you can apply is fixed. So now you need to use the impulse momentum theorem to give the biggest possible acceleration to the object, in this case, a tennis ball, which has a mass of 57 grams. Okay, sorry, there's some extra marks here on the whiteboard. Okay, so the question says, what speed does the ball leave her racket if the time in contact is 5 milliseconds? Okay, what is the final velocity? You can assume that the initial velocity is 0. And then they're going to say, okay, well, what if her coach gets her to follow through and keep that tennis racket in contact with the ball for a little bit longer? 6.5 milliseconds. Okay, so we'll compare the speeds of the balls. And we're going to use the impulse momentum theorem to do that. So we have F delta T equals delta P, or we can say M delta V, because the mass of the tennis ball isn't changing. It's just the velocity. So F delta T then, 560 newtons times 0.057 kilograms. Remember to convert to kilograms when you need to. And we get a change in momentum of 2.8 kilogram meters per second. And that is the mass of the ball times the final speed. So we back out the mass and we get a final speed of the ball, 49 meters per second. All right, well, that's pretty fast. But what happens if I can increase the time that I'm in contact there? So now our F delta T is going to be 560 newtons times 0.0065 seconds, which gives me a new final momentum of 3.64 kilogram meters per second. And just like we did before, we back out 64 meters per second. I think it asks what factor, by what factor is it increased? So we've got our 64 meters per second is our final, divided by our initial idea of 49. So that's a factor of 1.3. So she's increased the speed by 1.3 times. And if you notice, that is the same factor as the time increased by, right? 0.0065, right? 0.0065 is 1.3 times 0.005. So this is a linear relationship, kind of like you might have expected from the formula, right? What happens to the final velocity if you increase the time by a factor of 1.3? Well, you increase the velocity by a factor of 1.3. So if you're starting to understand that factor of change method, keep that in mind for either checking your results on a question or answering a question very quickly in a multiple choice situation. So that, again, is our impulse momentum example for topic 3.